Okay, in this video, I want to go for example 2 of solving the three-variable system of equations. So we got these three equations named capital A, B, and C. Looking at this system of equation, I feel like eliminating the variable z is going to be easier for me than eliminating x and y. Simply because of the fact that I recognize that the coefficient plus 2 is one of the multiplicative factors of itself, of 6, and then of 4. So I'm going to select 2 out of these 3 equations. So namely, I'm going to select A and B first. And of course, when we deal with three-variable system of equation, always name your step and name your equation. So that makes it easier when you trace it back to solve for all of the variables. So A is 2x plus 2y plus 2z equal to negative 14. B is 4x minus 9y plus 6z equal to 19. Now, I'm going to label them again, because in the previous video, I didn't do that. Now, looking at the plus 2z and the plus 6z, again, the plus 2 is a multiplicative factor of itself and of plus 6. So I can easily convert the plus 2z into the opposite of plus 6z, which is minus 6z, by multiplying the entire equation A by negative 3. If I were to do that, my new equation A can be found by distributing the minus 3 to each of the term inside the parentheses. So distributing the minus 3, I would have minus 6x minus 6y minus 6z equal to positive 42. And of course, equation B is going to stay the same. And then when we add them vertically, guess what? Minus 6z and the plus 6z cancel out. So we're left with minus 2x minus 15y equal to positive 61. And I'll denote this equation by capital D. So that's the name of this equation. Now, go back to the original 3 equations and select 2 other ones and do the same thing. Eliminate the z variable. So I'm going to select capital A and capital C this time. So 2x plus 2y plus 2z equal to negative 14, and minus 3x plus 2y plus 4z equals to 34. And just like in the first step, since the coefficient plus 2 is a factor of itself and a factor of plus 4, I can convert the plus 2z into the opposite of plus 4z, which is minus 4z, by multiplying this entire equation A by negative 2. So distributing the negative 2 to each of the terms inside of parentheses, I would have negative 4x minus 4y minus 4z equal to positive 28. And my C equation is going to stay the same, so bring it over. And then when we add them vertically, minus 4z and plus 4z cancel out, so we're left with negative 7x minus 2y equal, this is going to be 62. Yep. So I'll denote this by capital E. So grouping equation capital D and capital E together, that is going to be our two-variable system of equation. So I got minus 2x minus 15y equal to positive 61, negative 7x minus 2y equal to positive 62. Now looking at this looking at these two equations, the next variable that I want to eliminate is going to be the variable y. No, not variable y, I mean, let's go with the x instead because it seems easier than the y. So I want to eliminate the x variable now. When I compare the coefficients -2 and -7, -7 is not a multiple of -2, and -2 is not a factor or a multiplicative factor of -7. So I had to find the least common multiple of -2 and -7. Well, that is going to be either -14 or +14. So if I can convert one of these two x terms into -14 and the other one into +14, then when I add these two equations, d and e, vertically, I will be able to cancel out the x variable. So I would say I'm going to make the top equation, the top x term, minus 2x, into positive 14x, and the second one into negative 14x. So for equation D, I'm going to multiply everything by -7. And for equation E, I'm going to multiply everything by +2. So my new equation E, when I distribute the -7 to each of the term inside the parentheses, I'm going to have 14x plus, because negative times negative is positive, 105y equals, let's see, 7 times 1 is 7. 7 times 6 is 42. So this is going to be -427. What about my equation E? Sorry for moving the paper a little too much here. I want to make sure you guys see everything. Distributing the +2 to each term inside the parentheses, I'm going to have -14x minus 4y equal +124. So when I add these two equations vertically, guess what? 14x minus 14x cancel out. 105y minus 4y is going to be +101y. -427 plus 124. What is that going to be equals to? Well, 7 minus 4 is 3. 2 minus 2 is 0. 4 minus 1 is 3. And when I pluck out the negative side, I realize that +427 is greater than +124. So the minus side has to go with the result. So divide everything by 101 to solve for y. I got y equal to -3. That's one variable now. But with y equal to -3, I now get to go backward to selecting either equation D or E to evaluate the x, and then take the x and y, go back to one of the three original equations to solve for the remaining z. So let's see, I'm going to select equation D instead, because it seems like -2 and -15 is easier for me to deal with. Okay, actually no, equation E instead. Never mind. So choose E. So E is -7x minus 2y equal to 62. But y is -3. Replace y with -3. So I would have -7x minus 2 times -3 equal to 62. That would give me -7x. -2 times -3 is +6 equals 62. Solving for x by first getting rid of the +6 and then a -7 by subtracting 6 to both sides, which will give me -7x equal 56, and then divide both sides by -7 to get x by itself. I got x equal to -8. So with x equal -8 and y equal -3, I get to take these two variables, plug it back into one of the original three equations. So I'm going to select A instead because I got all the positive coefficients, so it seems like it's going to be a little easier for me to deal with. So choose A. So I got 2x plus 2y plus 2z equal to negative 14. But x is negative 8, so I got 2 times negative 8. Y is negative 3, so I got plus 2 times negative 3. Keep the plus 2z and keep the minus 14 on the right hand side, like that. Well, let's see mental math. 2 times negative 8 is negative 16. 2 times 3 is negative 6. Negative 16 plus negative 6 is going to be negative 22 plus 2z equal to negative 14. Solve for z by getting rid of negative 22 and then the plus 2 by adding 22 to both sides. Bring down the plus 2z. Let's see, 22 minus 14, that's going to be positive 8. Divide both sides by positive 2. I get z equal to 4. So putting all the variables together in the triple pair of x comma y comma z, the solution is going to be negative 8 comma negative 3 and then comma 4. And yeah, this is how we do it, guys. So make sure that you start with selecting two of the original three equations. You eliminate one of the three variables, either x, y, or z. Go back, select two more, eliminate that same variables. After doing that, you're going to come up with two new equations, and these two new equations will only now have two variables, either x and y, x and z, or y and z, depending on which variable you're trying to eliminate at the beginning. Group those two new equations together and then eliminate the next one, either x or y, to evaluate the leftover one. After you evaluate the leftover one, just take its value and then go backward to eliminate the second one, and then take the two variables, go back to one of the three original equations, and evaluate the last one. All right. So it's a tedious process, but that's the reason why naming your equations and writing down the step that you're doing is really going to help you keep track of what you're doing. Because I have seen students who have shown work not really messy, but like just a little like out of order, and they still get confused when they try to go backward to eliminate this, to evaluate the second and third variables. So make sure you always name your equations and write out the steps that you're doing.